Hi, this is IvanBarnash speaking with the explanation of Assignment 3 for machine learning. So let's jump straight into it. So here we can see we are fitting CIFAR 10 dataset with a bunch of images of animals and vehicles into our model, which has these layers. So conv2d, max pooling, flatten, dense 1 and dense 2 layers, pretty much. So let's answer the first question and then I will explain the layers. So the question is, did the network present signs of overfitting? If so, in which epoch? So as you can see here, here is more accurate. From epoch 0 to epoch 20, the validation accuracy was rising along with the training accuracy, but then we can see in epoch 25 it started falling off, it started dropping, which means that and the training accuracy kept rising. So this means it started to create a complex rules and rely on specific neurons for the identification, for the classification. So pretty much it started to memorize the training set, right? So what this means, this is the overfitting when it just takes very specific patterns, very specific neurons, and then it will pretty much not be able to identify the image, image outside the training set as good as in the training set, because it started to create those very complex rules to identify images specifically in the training set. This is called overfitting. So we can see it here as well. As we can see, it's the validation accuracy started dropping. Validation accuracy being the accuracy of the model performed on the images it has never seen before. This is the accuracy on training. So yeah, oh yeah, also I wanted to say that this kind of figures, because even with the weight reduction from conv2d, from max pooling, we still get, in dense layer, we still get like 1 million parameters, which will result in overfitting anyway, because it's just way too much. And it will start memorizing. It will be prone to memorizing because there's just so much parameters. So then next question is how many layers this model has, and identify their types. So as I already said, conv2d, max pooling, flatten, and 2 dense layers. So explain what is the purpose. So conv2d, pretty much what it does, it will slide a small matrix 3 by 3. Well, in this case, it's 32 by 32, and create feature maps. Pretty much, what this is, it will slide over over the whole image, right? And it will output a value there. Pretty much highlighting the shapes, pretty much detecting them, right? Detecting the shapes, the needed patterns, shapes and stuff like that. So pretty much to find the feature, we need this conv2d. What it also does is, for example, if we feed the model raw image, like 100 by 100 pixels, it will be alive. It will be like 100 by 100 by 10 neurons. It's already 100,000 parameters, right? It's too much, and it will cause to overfit it. So the conv2d, it answers this issue by having so weights being shared, right? For example, if weights are like 3 by 3 by 10 feature maps, so it's only 90. So it's only 90. It's a huge step up. So then we have max pooling. What this does, it will pretty much squish those feature maps into the like needed features, for example. So it will, like a 2x2 matrix, for example. There's 2x2 matrix, and it will go through the whole feature map, and it will output the max value of the, like, this 2x2 matrix, right? Uh, and squishing the whole, like, matrix, the whole feature map into, in this case, into, as you can see here. Now it's 16 by 16 by 32 feature maps, right? We need this to reduce the amount of weight for more computational power, more efficiency. Then we have flatten, so we need to flatten those features to then pass it to the dense layer. Dense layer 128 ReLU, the place where the complex, rule creations pretty much happen. Where the model learns pretty much. Then we have another dense layer, pretty much the output layer, 10 softmax. What it does, so it has 10 neurons, and softmax will turn the probabilities into, the probabilities that equal to 1 if you sum them up, right? So that we have a basic classifications, right? So like 90% it's this, and 10% it's that, So here is the answer. I just wanted to answer it without looking. And then we are adding one more convolution layers. I added two. I added two convolution layers to that, and we look at the result. And as we can see, the result is very bad, because pretty much our accuracy, validation accuracy, did improve somewhat. We can see that now it peaked at 69, but it's still dropping to 66, 66.6, and training accuracy just skyrocketed to 99 and kept going. So what it means is that now it will learn on better features, right? Features that are more needed, more necessary, I'd say, but it will not resolve the issue of overfitting, because pretty much it still can memorize the whole set. It still can memorize the training set, right? The thing is, it doesn't like it doesn't worsen the situation, right? As we can see, the validation accuracy did increase a bit, but it just doesn't improve the situation at all either. Yeah, because it doesn't do anything to resolve the issue. It just gives it better features, but memorization is still there, right? And also more computation. So it compiled in 9 minutes, and the original one compiled in 2 minutes. And now we add a dropout layer. So what is a dropout layer? Dropout layer is a layer that will, each batch, it will randomly turn off some neurons so that the model exactly cannot memorize the training set, and will create more general rules, more general and robust rules. So this way the model cannot just rely on specific neurons, rely on specific patterns. It will rely on more general patterns, because some neurons are randomly turned off. It will be forced to do that. So as we can see, the accuracy, validation accuracy, is increased, and the gap is closed a bit. The gap between the validation accuracy and the training accuracy. It still has overfitting, but it just it still overfits, but now As you can see, accuracy validation, it's not dropping, it's just kind of hovers at this 72% value. And also what I wanted to say, sorry, I mean, yeah, I think I said everything I need, right? So yeah, it doesn't overcomplicate the rules that it creates. It now just creates more generic rules, and I already explained why. Because each batch, some neurons are turned off randomly as well. So yeah, this is the explanation of assignment 3. Thank you for watching. Bye.